Hello everyone, I hope you all are good and you all are practicing problems, learning concepts. Let us for now look at this question, and this is going to be one very interesting discussion. Let's start with this one. A solid sphere of radius r is released on a rough horizontal surface with its top point having thrice the velocity of its bottom point. ठीक है, सो इनिशियली हमारे पास सपोज कर लो हमारे हैंड में ये है एंड इट्स टॉप पॉइंट इज हैविंग वेलोसिटी 3v नॉट एंड बॉटम इज हैविंग वेलोसिटी v नॉट, और हमने इसे एक सरफेस पे रख दिया है जिसके पास फ्रिक्शन है। तो पूछ रहा है कैलकुलेट द लीनियर वेलोसिटी ऑफ सेंटर ऑफ अ स्फीयर व्हेन इट स्टार्ट्स प्योर रोलिंग। सो व्हेन इट विल स्टार्ट प्योर रोलिंग, व्हाट विल बी द लीनियर वेलोसिटी ऑफ द सेंटर ऑफ स्फीयर। डन है। सबसे पहले टच करने से पहले इसके मोशन को एनालाइज करते हैं, कैसा मोशन है। आप ध्यान से देखो, इसके दो पॉइंट की वेलोसिटी डिफरेंट है, सो डेफिनेटली दिस इज नॉट प्योर ट्रांसलेशन। इन केस ऑफ प्योर ट्रांसलेशन, बॉडी विल हैव व्हाट, body will have equal velocity at each point, equal to the velocity of center of mass, right? But here it is different, so it is sum of both translation and rotation. Then and since these 2 points are at the periphery, basically we cannot say it is in pure rotation around center of mass, right? It is not. I mean, in that case, again these 2 points will have equal velocity because they are equidistant from this center of mass thing. Okay, so that's not the case. We will say that this is in translation plus rotation. अब देखो, अगर ये ट्रांसलेशन प्लस रोटेशन में है, then its center of mass is having certain velocity and again it is rotating. Now the case is, or the question is, in which direction it is rotating, clockwise, anti-clockwise, what is the value of omega? देन कैसे निकाल सकते हैं? आपको पता है, अगर तो दो पॉइंट की वेलोसिटी दी हुई है, देन वी कैन कैलकुलेट ओमेगा इजीली, एंड हाउ वी डू, सिंपली कंबाइन दोस 2 points and see what is the velocity perpendicular to this joining line. So this 3v naught and v naught is basically perpendicular, so we can write angular velocity omega as 3v naught minus v naught, 2v naught by distance between them, that is your 2r. So this will become v naught by r. But the right way to do it, I will suggest, जैसे a point है, यहाँ b है. So if 2 points velocity is given in the body, we can calculate omega from the relation v equal to omega cross r. ठीक है? So let us talk about everything of b with respect to a. So VBA, velocity of b with respect to a, is equal to omega cross position vector of b with respect to a. Now omega का direction हम यहाँ से easily निकाल सकते हैं. आप देखो RBA, it is in this direction, right? Let us say this is in which direction? This is y direction, let's say, and this is x direction, because in this direction is the BBA, right? 2v naught. Now, if RBA is along J cap and VBA is along I cap, then omega cross will be along which line? Along which direction? So it will be along minus k cap, क्योंकि आपको पता है I J K, J cross K करोगे, sorry, K cross J करोगे, you will be getting minus I. So minus K cross J करोगे, you will be getting plus I. So this should be minus k cap. It means clockwise. So it is clockwise. ऐसे भी आप जानते हो ओमेगा का डायरेक्शन जो होगा, I mean it will be perpendicular to the plane of this motion, right? So omega cross r, if you're doing here, it will be omega r sine 90. So magnitude wise, if you calculate it, VBA ka magnitude is 2v naught, and this is equal to omega into RBA ka magnitude, that is 2r into sine 90. So omega is what? V naught by r. So now we know that question is like, we have a ball in our hand which is rotating with v naught by r, and which has its center of mass moving with certain velocity, and that velocity now we can calculate. जैसे यहाँ पे आप ध्यान से देखो, what is this given? I mean, velocity of this point will be equal to how much? Let's say its center of mass has a velocity of VCM. So VCM, this point will have velocity VCM plus omega r. This is 3v naught, and this thing will have velocity of VCM minus omega r, and this is equal to how much? V naught. So इन दोनों को अगर आप add करते हो, 2VCM will be equal to 4v naught, and VCM is equal to how much? It is 2v naught. So VCM तुम्हारा क्या है? 2v naught है. Done है? So this is 2v naught. Now we know that this is translating with velocity 2v naught and rotating with angular velocity v naught by r, and now it is allowed to touch the ground. It is left on the ground, released on the ground, right? So it is said that when it will start pure rolling, what will happen to its linear velocity? कितना होगा? डन है। सो दो मेथड से निकाल सकते हो, एक तो फोर्स और टॉर्क का इक्वेशन लिख के यू कैन डू दैट, आई विल टेल यू ऑल्सो, बट इजिली यू कैन डू बाय कंजर्वेशन ऑफ एंगुलर मोमेंटम। कैसे? जैसे देखो ए पॉइंट को टच करने से चेंज क्या हुआ, चेंज ये हुआ कि फ्रिक्शन लगा, फ्रिक्शन विल एक्ट इन दिस डायरेक्शन एंड बिकॉज ऑफ दिस फ्रिक्शन टॉर्क विल अराइज। लेकिन अगर हमने कोई भी पॉइंट यहाँ पे लिया, इसके अराउंड इफ यू टॉक अबाउट टॉर्क, देन इसके अराउंड torque of friction will be zero because it is passing through point P. So P के अराउंड आप एंगुलर मोमेंटम कंजर्व कर सकते हो, क्योंकि जब आपने टच नहीं करवाया था तब भी mg लग रहा है, टच करवा रहे हो तब भी mg लग रहा है। सो mg इज नॉट क्रिएटिंग डिफरेंस, डिफरेंस विल गेट क्रिएटेड बाय फ्रिक्शन। एंड फ्रिक्शन यहाँ पे क्या है तुम्हारा, फ्रिक्शन इज बेसिकली पासिंग थ्रू पॉइंट P, इसका टॉर्क जीरो है। सो P के अराउंड हम एंगुलर मोमेंटम को क्या कर सकते हैं, कंजर्व कर सकते हैं। सो लेट अस कंजर्व एंगुलर मोमेंटम अराउंड P। इनिशियल एंगुलर मोमेंटम अराउंड P क्या होगा? सो एंगुलर मोमेंटम बिकॉज ऑफ लीनियर मोशन, सो आर क्रॉस एम बी करोगे, ठीक है। सो आई मीन दिस इज द लाइन ऑफ मोशन, लीनियर मोशन, सो आर क्रॉस एम बी, आर इज दिस वन, so this will be equal to radius, so radius into mass into velocity to v naught, right? And this is in which direction? In this direction. और रोटेशन की वजह से क्या होगा, देखो इट इज मूविंग इन दिस डायरेक्शन ऑलरेडी, सो आई सी एम इंटू ओमेगा। आई सी एम क्या होगा तुम्हारा, 2/5 mr² ओमेगा, राइट? सो दिस इज ओमेगा, ओके, एंड दिस इज वी नॉट बाई आर। अब आप इसको सॉल्व कर लो, आई मीन ओमेगा को चलो मैं वी नॉट बाई आर ही लिख देती हूँ। सो दिस इज दिस, नाउ यू सॉल्व इट, दिस विल बिकम हाउ मच, 2m v0r plus 2/5 m v naught r. So this is equal to 12 m v naught r by 5. And when it has started pure rolling, in that case what you can see or what you can say, pure rolling के case में क्या होने वाला है, this is vcm let's say, and let's say its angular velocity is omega, then we know that vcm will be equal to how much, omega naught by, sorry, vcm will be equal to omega naught r. Then this is the case, right? Because in pure rolling, this point will have zero velocity. So whatever velocity it has because of translation, because of rotation will be same. Done? So VCM is equal to omega r. And now if this is the case, so final angular momentum आप क्या लिखोगे? So basically you simply replace the thing m into r into VCM, ठीक है, plus ICM that is 2/5 mr square into omega. Omega को आप क्या लिखोगे? You will be writing this as VCM by r. So this is equal to how much? This is your mr VCM plus 2/5 mrvc, right? It is this one. So this will become how much? This is your 7/5 mrvc, and this has to be equal to initial angular momentum, which is equal to 12/5 mv naught r. So 12/5 mv naught r को आप किसके बराबर लिखने वाले हो? You will be writing this as equal to 7/5 mrvcm, ठीक है। So mr को आप कैंसिल कर दो, and what you will be getting for this one, I mean इनिशियल एंगुलर मोमेंटम का डायरेक्शन हमने सही लिखा है ना, या दिस इज इन दिस डायरेक्शन, राइट? या सो दिस इज दिस वन। अब यहाँ से आप आंसर निकाल लो, VCM विल बी इक्वल टू हाउ मच, VCM विल बी इक्वल टू 12/7 V naught. This is going to be your answer, okay? So this is this. Now let us solve it from the second method. Let us do this one. देखो यहाँ पे क्या लगा था, फोर्स क्या लगा है, यहाँ पे फ्रिक्शन लगा है, राइट? So this is friction. Now friction will do what? Friction will retard linear motion, right? Because linear velocity is in 2 v naught in this direction, right? So it will retard. So acceleration will be how much? F by m. And final velocity at any time t can be written as initial velocity minus F by mt. And if you talk about torque of this around center of mass, it will be r cross F, right? So it is in which direction? It is in clockwise direction. So basically it will act in the direction of omega. So omega at any time can be given as omega naught, this is v naught by r, plus torque, which is your equal to fr by f cross r divided by I alpha. Alpha we are going to write alpha t, क्योंकि देखो टॉर्क क्या लगा तुम्हारा, f into r. I torque can be written as I alpha fr. Alpha is equal to fr by I. I is how much? 2/5 mr square. So this will become equal to 5f by 2mr. So this is 5f by 2mr, okay, into t. So इसको आप लिख लो v naught by r plus 5f by 2mr t. Now, when this rolling will occur, in that case, V at that time will be equal to omega R at that time, right? So V equal to आप कर लो omega R. So V को आप क्या लिखोगे? V को लिखोगे 2 V naught minus F by M T, and this is equal to V naught by R plus how much is that? 5F by 2mr. So this is 5F by 2mr into T. अब आप इसको सॉल्व कर लो. सो दिस इंटू ओमेगा यू विल डू, सॉरी आर यू विल डू ओमेगा इंटू आर. सो दिस विल बिकम वी नॉट एंड दिस आर आर विल गेट कैंसिल. सो 2 वी नॉट माइनस वी नॉट करो, वी नॉट वी विल बी लेफ्ट विथ एफ बाई एम टी को इधर लेकर जाओ. सो एफ बाई एम टी प्लस 5f by 2m into t, and this will be equal to how much? This will be equal to 7ft divided by this is equal to 2, right? 2m. Okay, so this is this. अब देखो v naught is equal to this one. So what is the value of time we are getting? This is 2m v naught by 7f. Put the value of this time in first equation. Let us call this first equation. यहाँ पे time t का value आप put कर दो. So if you put it here, you will be getting velocity. So v equal to 2 v naught minus f by m into t, that is 2m v naught by 7 f, right? So इसको आप cancel करो. This will be equal to f f m m, and this is 2 v naught minus 2 v naught by 7. So this will become how much? 14 minus 2, that is 12 v naught by 7. So that is what we have got from the earlier method also, right? So earlier method में हमने angular momentum की बात करी, और कोई भी बॉडी जो रोटेट कर रही होती है, ट्रांसलेट भी कर रही होती है, उसका एंगुलर मोमेंटम हम कैसे लिखते हैं? लीनियर मोमेंटम, लीनियर no sorry, linear momentum नहीं, angular momentum because of linear motion, that is r cross mv, ठीक है, plus angular momentum because of rotation, that is always written as ICM, moment of inertia around center of mass into omega. So I repeated it because I forgot to mention this categorically, so that is why I've done it here. Chalo, this is sorted, right? Now let us go to this portion. This is a very small portion but is still significant. इसको थोड़ा एनालाइज करते हैं. देखो क्वेश्चन में ये कह रहा है वी हैव अ स्फीयर एंड दिस इज इनिशियली रोटेटिंग इन दिस डायरेक्शन and it is translating in this direction, and then it is gently kept on the surface which has friction. Done it? So अगर आप यहाँ पे check करो, because of translation and rotation, bottom point will have velocity in this direction. So v naught plus omega naught r. We don't know v naught and omega naught relation. We don't know they are equal or unequal, greater or smaller. We don't know that. In nothing we know, right? We just know they have velocity in this direction, angular velocity in this direction. Then they are gently kept on the surface. So first case ये कह रहा है slipping ceases before the sphere loses all its linear momentum. So sphere जब linear momentum lose कर रहा है, I mean no, slipping ceases. So basically rolling starts before it loses all its linear momentum. It means the moment rolling start, before that there is no moment when velocity of body has become zero. अब देखो यहाँ पे rolling के लिए इस point की velocity हमें zero चाहिए, ठीक है. So somehow omega naught should get reversed in this direction, because before rolling center of mass velocity is not becoming zero at any moment. So velocity will, I mean its magnitude will change, but it is going to stay, right? So velocity of this point because of translation will stay in this direction. So because of rotation we need to make it in this direction, right? So because of, I mean initially it is rotating in anti-clockwise sense, we need to make it rotate in clockwise sense in order to reach to this conclusion, ठीक है. So the moment it will touch the ground, what will happen? देखो यहाँ पे लगेगा क्या? Friction. Because this point has net velocity in this direction, friction will act in here. So acceleration will be f by m, and because of this velocity is going to decrease, v naught minus f by mt. And omega can be written as, initially omega will what? Omega is in anti-clockwise direction and torque will act in which direction? Clockwise, ठीक है. So minus alpha t. Alpha क्या होगा देखो? Alpha will be torque is fr divided by I, that is 2 by 5 mr square. So this is 5f by 2 mr. This is alpha, right? So this will become how much? Omega naught minus 5f by 2 mr t. नाउ व्हाट यू कैन टॉक अबाउट दिस वन. अब देखो यहाँ पे क्या होगा, सबसे पहले ओमेगा किसी टाइम पे जीरो होगा, डन है. एंड आफ्टर दैट at what time it will become zero? So it will become zero when omega will become zero. It means omega naught will be 5f by 2 mrt. So t will be equal to 2 mr omega naught by 5f. After this time, what you can talk about omega? Omega will be equal to alpha t, right? After this time, done it. So let's say this is t1. So after t1 time, omega can be written as this one. So it will start gaining angular velocity in this sense. And then after certain time, after this time t1, it will start rolling. Done it. So in order to calculate relationship between V naught and omega naught, we know that when omega naught has become zero, at that point velocity is greater than zero, right? So at this time velocity will be greater than zero. So आप उस टाइम पे velocity को greater than zero कर दो. V naught minus f by m into t. T is how much? T आपने यहाँ से निकाला है. T is 2 mr omega naught. So 2 mr omega naught by 5f greater than zero. एफ एम को आप कैंसिल कर लो यहां से, एंड दिस इज वी नॉट इज ग्रेटर देन 2/5. This is how much? Omega naught r. This is the relation. Now let us talk about second case. In second case, what we are asked, the sphere comes to a permanent rest after some time. Permanent rest का मतलब ओमेगा भी जीरो हो गया है, वेलोसिटी भी जीरो हो गया है. So is it like at the same time both will become zero? And if not, then is it possible? Suppose कर लो velocity पहले zero होता है. So अगर velocity पहले zero होता है, it means omega is still there. And if omega is still there, then this point will have certain velocity, right? And let's say velocity became zero first. Let's say. So अगर velocity पहले zero हो जाता है, then omega naught is in which direction? Is in this direction, and because of which it will have velocity in this direction. So friction will act in this direction. And then this friction will try giving it linear velocity in this direction. So again, there will be a case of rolling. It may happen, right? It will happen actually. Done it. So actually both have to gain zero velocity at the same time in order to come to permanent rest. Done it. And अगर same time पे zero करना है, then what you will do? V equal to omega r आप कर दो at time t. So at time t, if you do this, you will be writing V naught minus f by mt will be equal to how much? This will be equal to omega naught r minus this is how much? 5f by 2mrt. So this is 5f by 2mrt. Okay. So again, t का value, both are becoming zero at the same time. लेकिन equate करने से हमें आंसर नहीं मिलेगा. एक काम कर लो, इसको पहले zero कर लो. Again, t का value same मिलेगा, same as before we have got. So t value will be equal to how much? This is okay. Omega को zero कर रहे हैं ना, r was not there. So omega t will be 2mr omega naught divided by 5f. And at this time t, velocity is also becoming zero. So अब आप एक काम करो, velocity वाले expression में इस value को put कर दो. So v equal to v naught minus f by m into t करो. So into t करोगे 2mr omega naught 2mr omega naught by 5f, right? So this will get cancelled and you will be left with what? V, this is becoming zero, right? So V naught is equal to 2 by 5 r omega naught. So इतना कैलकुलेट करने की जरूरत नहीं थी. देखो फर्स्ट केस में हमें क्या आया था? We have got it greater, right? In this case, we have got it greater. In second case, this will become zero. V naught minus this will become zero at that time when omega is becoming zero. And in third case, velocity of center becomes zero before. So V is becoming zero before slipping starts. So in that case, basically आपको क्या करना है? Velocity पहले zero होगा and at the time velocity is becoming zero, ओमेगा इज नॉट जीरो, राइट? सो वेलोसिटी को आप पहले जीरो कर लो. v इक्वल टू क्या है? v नॉट माइनस f बाई एम टी. सो इफ इट इज बिकमिंग जीरो, देन t इज इक्वल टू m v नॉट बाई f. So at this time, velocity, linear velocity is becoming zero. And at that time, omega must be greater than zero. That is why rolling will occur, right? So omega greater than zero आप कर लो. Omega value was how much? Omega naught minus, it is how much? 5. This is alpha is how much? 5f by 2mr, right? So this is 5f by 2mr into t. T is how much? M v naught by f. And this is greater than 0, right? Omega naught is greater than 0. So m by f को आप cancel कर लो, you are left with what? 5 v naught by 2. So omega naught is greater than 5 v naught by 2. So if you write it, 5 v naught by 2 is less than omega naught. R thing should be there. I mean, this is by R thing is there, right? One R is left, 2 के साथ. So this is this. So you can see here 5 V naught by 2 is less than omega naught R, means omega V naught is less than how much? It is less than 2 by 5 omega naught R. So first case में क्या होगा तुम्हारा? First case होगा, what was that? Let me check it. Yes. In first case, omega naught is what? I mean, in first case, V naught, we have got greater than 2 by 5, that was right. Yes. In first case, it is 2 by 5, greater than 2 by 5 omega naught R. In second case, it is equal to 2 by 5 omega naught R. And in third case, it is equal to V naught less than 2 by 5 omega naught R. Okay? So these are the relation. So I hope you have understood this question. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye-bye.